Okay, so this is section 10.5 homework. So we're going to start with problem number 4. So it says, if you toss 7 fair coins, in how many ways can you obtain each result? So 4 says at least 2 heads. And it says at least 2 is the complement of 0 or 1. So this is the case where you find all the possibilities and then you subtract off the complement. So at least 2 means 2 or more. So the opposite of at least 2 heads is 1 head or no heads. So to find, so you need basically the universal set. So the question is, how many combinations can you get if you flip a coin 7 times? Well, the answer is 2 to the 7th. That's because you have a 7-step process, which each step requires has 2 outcomes. And 2 to the 7th is, let's see what it is, 2 to the 7th power is 128. So then you do the things that are opposite of at least 2 heads. So 1 head. So 1 head, there are 7 ways to do that. Because if you can have the head in the first position, the second position, third position, and so forth. 0 heads, which means all tails, there's 1 way of doing that. So the number of at least 2 heads is going to be the total number of possibilities, which is 128, minus the number of ones that have 1 head, minus the number of heads that had no heads, and you get 120. Okay, next one is 6. At least 1 of each, a head and a tail. Okay. So how do we do that? So I'm trying to think about that. Okay, yeah. So we still have the same number of total possibilities. So the total equals 128. And there are really only 2 possibilities that that are opposite of at least 1 head. That means two possibilities of the complement. And those are all heads. So there's, in that case, there are no tails. Or you can have all tails, and that has no heads. So those are the only 2 possibilities. So the final answer is 128 minus 2, which is 126. Okay, we have 8. If you roll 2 fair dice, say red and green, in how many ways can you obtain each result? It says a sum of at least 3. So we did this earlier as a table. If you remember, we made a table up. There were 36 possibilities. And if you wrote them out, the only one that was a 2 was 1 plus 1. So if you did 1 plus 2, you get 3, or 2 plus 1, you get 3. So the complement of at least 3 is 2 or less. So the total number of possibilities is 36. The number of possibilities for the complement is 1, this one right here. And so the number of 3 or greater than or equal to x is greater than or equal to 3, which is the sum, x is the sum. It's going to be the total number of possibilities minus the complement, which gives you 35. Okay, number 10, same grouping here. A different number on each die. So the complement of a different number is the same number. Again, if you remember that table that we set up, we had the diagonal where they had the same number. So there were 6 of those. 2 1s, 2 3s, 2 2s, 2 3s, etc. So there are 6. So the number of possible arrangements where you have a different number is going to be the total number of possibilities minus 6. The complement of what we're looking for. So the answer is 30. Okay, we're moving to 15. So choosing country music albums. Jeannie Brownson's collection of 10 country music albums includes Southern Voice by Tim McGraw. Jean will choose 3 of her albums to play on a drive to Nashville, assuming order is not important. Okay, so order is not important. That means we do the complement. And the total number of possibilities that she could have out of her 10 albums, chosen 3 at a time, would be this. Now, she says, how many different sets of 3 albums could she choose? So that's the answer. So there's no restrictions on that. So you have 10 factorial divided by 3 factorial times 10 minus 3 quantity factorial. So you get 10 factorial over 3 factorial times 7 factorial. 10 factorial can be written as 10 times 9 times 8 times 7 factorial. You see, I can replace this with 1. And then I can expand the denominator out 3 times 2 times 1. And I could just do the multiplication. I can simplify here a little bit. 9 divided by 3 is 3. 8 divided by 2 is 4. So I get 10 times 12, which is 120. So there are 120 different ways that you can do that. Now, how many sets of these voices would not include Southern Voice? So the ones that wouldn't include solids, what you do there is you take 9 things, taken 3 at a time. So you remove one of the albums, which is Southern Voice, and you do that. So you get 9 factorial over 3 factorial times 9 minus 3 factorial, which is 9 factorial over 3 factorial times 6 factorial. We rewrite 9 factorial as 9 times 8 times 7 times 6 factorial. So the denominator stays the same. replace that with 1. Get 9 times 8 times 7 over 3 factorial, which is 3 times 2 times 1. So 9 divided by 3 is 3. 8 divided by 2 is 4. So we get 3 times 4 times 7, which is 84, I think. So then the final question is the one we use the complement for. How many of them would include Southern Voice? So these are all our choices that include Southern Voice, and well, just all of the choices. These are ones that don't include Southern Voice. So the answer to part C would be the total number of choices, taking everything into account, the total number of choices without Southern Voice. And so the 36 out of the 120 arrangements or sets do contain Southern Voice. Because you might think it's just 1 out of 10 albums, so that it should be 1 out of 10, but that's not the way it works. Okay, do one more in this grouping, and we'll move on to another group. So 23 is counting radio call letters, and okay, yeah, it's a separate problem. Radio stations in the United States have call letters that begin with either K or W. Some have a total of 3 letters, and others have 4 letters. How many different call letter combinations are possible? Count all possible of these, even though practically some may be inappropriate. So this is not using the complement principle. This is using the AND principle. So we have some that are 3 letters, and we have some that are 4 letters. So you do each one of those separately, and then you add them together to get the total number of possibilities, because they're pretty much independent. So if you got a 3 call letter, the first one has to be either a W or K, and it doesn't say anything about that you can't repeat them. So you can use all 26 letters for the second space and all 26 letters for the third space. So this is a 3-letter call. What do they call them? Call letters. Station identification. So that is going to be equal to 2 times 26 times 26. So that's 1,352. 3-letter call letters. And then we have 4. So it's the same thing, except we have one more letter. When we have one more slot to put a letter. So it's going to still be 26 because we can reuse them. So you multiply those together. So you just take the previous result and they multiply it by 26. So that's 35,152. And so the total is going to be the sum of the two. So we don't multiply them together. Total combinations. They say combinations, I guess we could really call them arrangements, because that makes us confuse it with the official combination thing. It's just the sum of the two. So you take 1,352, and you add 35,152. 2 plus 35,152, and you get 36,504 possible radio stations. Okay, so we're going to stop there and we'll do another video for the second group of problems.